Hey guys, my name is Sandeep Patel. In this video, we are going to solve a problem called finding the maximum element from the given array using the recursion technique, right? Okay, so in this problem, we are given an input. Um, this is the input array that has the values 8, 11, 50, and 1, right? So the maximum element from this input array is 50. So that's the output of this problem, right? So, and this is what we're trying to solve. So in my previous video on recursion, where I said that we can solve the recursion problem using two-step process. First, breaking the problem, right? So we need to break the problem so that it becomes smaller, right? And how do we do that? So basically, we start with the full array and then we're reducing one element from the array, right? So let's start with that first. So let's say step number 1, break the problem in smaller subproblem, right? So how do we do this? So basically I'm gonna call the same find max function and removing one element from this array, right? So this is the way you can break the problem into subproblem. So let's look at how this works, right? So let's say the first call, I made a first call. So the first call is like this, right? So I'm calling the find max function and I'm passing the array, right? So now what am I doing here? Like I'm returning and calling the same function and reducing one element from the array, right? So basically I'm making another call to find max function and by removing the first element from the previous array, right? So now this is a new call, right? Which in return make another call where it reduced the first element from the array, right? So it's gonna be like this, right? And then finally, so we had 4 elements, then it become 3, 2, 1, and then lastly we have no element in the array, right? Okay, so now you need to notice this, right? We don't have any termination here, which means if I run this code, it's gonna go in infinite loop. It's still going to process further, right? But we want to stop that. We don't want to go beyond this empty array, right? Because that is the smallest problem, right, that we can solve, right? So we can say what is the maximum of the empty array, right? So we can say let's return maybe -1, right? Let's say -1 or 0. We can assume this is on you, like you have to assume the base case, right? So in this case I would assume that the empty array has 0 maximum element, right? Like the 0 would be the max of the empty array, right? So let's address this second step, right? Solving subproblem. Solving subproblem, right? So this is our base case. So what do we do here? So when we encounter array length triple equals 0, when array length becomes maybe let's say less than equals 0, in that case we return 0, right? So this is our base case. Now the loop will, now the function will stop executing it from this, right? It's not gonna go beyond this, right? So this is our base case where it stops, right? So that is our base case. So what happens here is that from this line of code it start to return, because now we return when element length becomes 0, right? So it's gonna return 0 to the previous function, right? And in previous function we are just doing the return from its previous function, right? So basically this 0 will be returned all the way up to the first call, right? So let's say if we console log of these functions, it's gonna return 0, right, for all, right? Even though that is not what we want, right? What we want is to find the max, right? So how do you find max? So let's say that each time when we are calling the function, we are reducing one element, but we're not using that one element. What if we use this element to compare with the previous one, right? For example, let's say that when I remove 8, What if I say I want to find max of 8 and the subproblem, right? What if I say this, like I want to get, so the element that I remove, right? So I want that element and whatever the max element from this, right? I do the same thing from here, right? I would say max of 11 and the max of the subproblem, right? And then here max of 50 and max of this, right? And when we hit the base case, right, it's gonna say okay, max of 1, and then this is our base case, right? So now find max when the element has no values, right? Like there's 0 element, right? At this point this will be replaced with 0, right? Because we are returning here, so this will return 0, right? And when this returns 0, what, and this function, when we call this function, it expecting the output from this function, right? So what is the max from 1 to 0, right? So I would say 1, right? So that's a maximum value, so this will be replaced by 1 here, right? And now it will try to find the max of this 2, which is 50, right? So which will be replaced by this function call, right? And then we have still 50 max, right? So it's going to be replaced by this, right? And then max, we still have 50 as a max, and that would be the output, right? When we return call from that to that, right? So let's do that. So what we need to do here is that we use math.max function, math.max function, and what we do is, so we slice the array from, I mean we remove the first element, but we're not using that, so we use this first element, right? And that is it, and that simple it is. So if I run this code, now you can see, so when we have when we pass the blank array, the output should be 0, right, which is correct. When we find max of single array element, then the maximum would be the same element itself, right? So that we get that. And when we find our use case like this input, and then the output is expected 50, so that's correct, right? So this is how you can solve problem using recursion. So now we need to calculate the time and space complexity of this problem, right? So when, if you remember, when we broke the problem down, right, basically what we did was we're reducing the element one by one until we get to the 0, right? So for example, so we had 5 element before, then we went to 4 element, then we went to 3 element, then we had 2 element, then 1, and then down to 0, right? So this is how we went, right? From 5 until the array length becomes 0, right? So can we say that, let's say n is equal to array.length, right? Then how many times this recursion happens, right? So recursion start from n, which is array length. Let's say this is array of 1, 2, 3, 4 element, right? Where n equals array length, which is 4, right? So we started with 4 elements from the array, and then we shrink down to 0, right? So from 4 to 0, which is n times, right? Can I say that this is n time? So this function call would be n time, right? And this is a static, so this statement is a constant time, right? Why constant time? Because it is not dependent on the input, right? It's not growing with the input, right? So let's say if you run this line of code one time, what happens is this line of code will execute one time, right? But there's a recursion happen that calls multiple times, right? So no matter how many times run, this will return, this line will run one time, but this line run n times, right? And so that's the time complexity of this recursion, right? So however many times this function called, that would be their time complexity for this. How about the space complexity? So in space complexity, we look for any variable declarations or call stack, right? So in this, we don't have any variable defined within the function, but we do have the callback, right? When you call the recursion, the call is added in the call stack, right? And that is counted towards space complexity. And how many time it added the call stack is the same thing, right? We had 4 element and 3 2 1 0, so n time, right? So this function was called n time, so it occupied n time call stack in the memory, right? And that's the reason why the space complexity is also O of n. Alright, so I hope you like this video. Please do like, comment, and subscribe. Thank you.